Hey, thank you, sodium, for coming by and caring. I grabbed your outer electron, I'm no good at sharing. Still you can stand in front of me in formulas. Admit it, you're more positive with me because I have your electron, that is true. And my outer shell is filled because of you. But you look like a noble gas too. You helped me and I helped you.
You're definitely not gonna win America.
With chlorine, chlorine, bromine, and iodine. We're hanging out by noble gases all the time. We're pretty needy and we're acting all unstable. Just wishing we were group 8 on the periodic table. Help us if you can, we're feeling down. We'd appreciate one more electron grant.
That's enough of that. There's more on YouTube than Charlie the Unicorn, okay? So there is chemistry on there. So some people have suggested that we should do like projects like that, stuff like that. And then we'll do a project.
Please don't.
No. I find that students hate projects. I hated them when I was a student. You know, or you could memorize the periodic table and sing it or something. You know, I don't know. But no, we're not going to do anything like that. So I just thought this song is appropriate for what we're going to do today with Chapter 6, because in Chapter 6 we're going to start learning what happens to the electrons and how does chemistry work. Okay, we're going to start talking about compounds and molecules and trying to understand where these electrons are going. So if you understood what they were singing about here, these are group 7, right? These are the halogens, and they need just one more electron. Why do they need an electron? So they could be like a noble gas. That's what the song told you, right? They want to be like group 8. What's special about noble gases? Anybody? They're happy. And why are they happy?
They have their H.
They have the 8 electrons. Their valence shell is full. So they're non-reactive. Okay? So we're going to talk about how things react to get to that point. Okay? So we're going to get there.
Are we going to do chapter 5 at any point?
Yeah. Some point. Whenever. Probably be like after we do chapter 9. The book is funny because this is like I've been at CCCC for 5 years, right? This is the 3rd edition of this book that I've taught out of. That's how often they change editions. The first edition was organized like this one. Then the last edition, they moved chapter 5. They put it right before chapter 10, and now they moved it back again. So, you know, they flip-flop. Yeah. Okay. We don't care about pharmacy text. We do a little bit, but okay. So ions. What are ions? So far we've learned about on the periodic table that an atom has the same number of electrons as protons, right? And the number of protons that an atom has tells us what? What's the number of protons an atom has? Tell me.
How many electrons?
Tells me how many electrons, and it tells me what element I have, right? It defines who you are. Okay. Well, there are times in life when an atom will gain or lose electrons. This picture is of sodium chloride. Anybody ever looked at sodium chloride? Everybody know what sodium chloride is? Table salt, right? It's a type of salt. Yes. Anybody ever looked at it? Like, that does not look like sand.
Is iodine same thing as?
Iodized salt's the same as regular salt. It all looks the same. You can't tell the difference. What kind of crystals? What do they look like? Little cubes, like little, like dice, right?
Yeah.
Like little ones. Anybody ever see? I've been doing it. I remember when I was about 10 years old, my parents owned a restaurant, and I remember putting salt on the table and looking at it to see what it looked like. Thanks. Appreciate it. Love y'all too. And then the cool thing to do is to take the corner of the salt shaker and break one crystal and see what happens.
Can you balance it on salt?
I was never that good. You could do that? Did you ever break one? What do you think happens if you break one of the crystals? It shatters into what? More little cubes. Why does it do that? Why don't you get like some circles and some triangles and has to do with the relationship of sodium and chlorine, right? And how they are lined up in that crystal. Okay? And it's unique to sodium chloride. Well, there are other crystals that look a lot like that, but it has to do with how they're fit together, right? You'll notice this picture here that there's the sodium would be the purple balls and the green would be the chlorides, okay? The chlorine's bigger than sodium because sodium becomes positive and chlorine becomes negative. So the question is, why are they doing this? Well, let's draw a picture. Here we start with sodium. How many protons does sodium have? 11 protons. And how many electrons does that have? 11 electrons. And then we have some chlorine over here. How many protons does chlorine have? 17 protons. How many electrons? 17 electrons. But if we look at the electron structure here, looks like that, doesn't it? The electron arrangement. You learned that in the last chapter, right? So let's look at this. If every element wants to have 8 in its outer shell, look at what we got going here. What if sodium said, hey, I got one, I'll give you, and you can put it right there. So now sodium just looks like 2, 8, and chlorine becomes 2, 8, 8. But now, sodium no longer has 11 electrons, it has 12 electrons, and chlorine now has 18 electrons. Right?
You can count them on both sides of the other share.
No, sodium gave its 1 electron to chlorine.
So then it doesn't flow, it has 10.
Yeah.
Oh, good Lord, I can't.
Yeah, I'm scared.
10, sorry.
I know
Thank
how to
you.
answer.
I
So bad.
Common Core math. Sorry. Hey, I'm ready to go home too, y'all, all right?
Yeah, he's been yawning. Man, we're just trying to feel like we're starting to get it, now you're messing us up.
I'm sorry. Yeah, so the total number of electrons has to stay the same, right? We started with 28 electrons, we still have to have 28 electrons. That's key, okay? The total number of electrons stays the same. But look, now sodium, sodium has 8 in its outer shell, and chlorine has 8 in its outer shell. Who does that look like? Who has 8 in their outer shell? The noble gases have full outer shells. 8 is full, right? So the slides are going to call this the octet rule. Things want to have 8 in their outer shell. I call it the noble gas rule. I want to look like the noble gas. Remember the song? It said if they wanted to be like a noble gas, they want to be like group 8. Go home and YouTube it. halogen help, the halogen song or something like that. I can't remember what it's called. Okay, so with sodium, it now has more protons and electrons, right? Everybody agrees with that?
Mm-hmm.
So we're going to write this as Na plus, if I can get the boards right. And now, chlorine has more electrons than protons. Because it has more electrons, it is negatively charged. Sodium has more protons, it's positively charged. Terminology. This is a cation. This is an anion. It didn't change.
Is that the actual definition of having more or less electrons?
Positively charged is cation.
Okay.
Negatively charged is anion.
Oh.
And because it's negatively charged, it means it has more electrons than protons. Now, it's still chlorine, right? Because it has 17 protons. But the name of this changes, and we'll talk about naming in a little while, okay? We'll talk more about naming on Wednesday, provided we have class.